number 1, we're just multiplying by the conjugate. Did any of you have any issues with number 1? Oh, well, actually number 5. Multiply by the conjugate, we're good. When we multiply by the conjugate, in the denominator, the outer and inner are going to cancel. And so all you really have to do is first term times last term. And up, we're going to FOIL. And when you do, that's what you get. Okay, so that's number 5. Now, number 6. If you remembered the formula, it was easy to plug it in. If you did not remember the formula, which was probably most of us, and that's me a lot of times too. I can't remember every formula. So what I do is I have to think about, okay, what would the pattern look like? And so since I'm looking at a pattern, do I just want to pick one term? Is one term a good pattern? No. If I just had 2 terms, would I be able to figure out a pattern? Not usually. I'd want to use at least 3 terms. So I let n be 3. So what are the first 3 multiples of 8? 8, 16, and 24. Well, what's the sum of 8 plus 16 plus 24? 48. Which one of these can I plug 3 into and get out 48? C. So even if you couldn't remember the formula at all, you can still find the answer to that problem.
I didn't understand what I was asking, though.
Oh, really? The sum of the first n multiples of 8?
Well, I don't know. I read it. Didn't make sense.
Okay. Does it make sense now, though?
Yeah.
Okay, good. So if we saw one similar to it, we'd be okay. All right. Number 7, we're back to the formula, is the easiest way to do it. Now, somebody said, can I make out a list and add them all up? Yes, it will work. It's time consuming. And on the end of course test, I'm fairly certain I would not spend that amount of time on one problem. I would probably guess an answer, circle it, and come back if it's something I knew I could do if I had a lot of leftover time. But the formula is, first you have to find the last term. So you do the a sub 1 plus n minus 1 times d, the common difference. Well, the first term is 30. We're looking at 12 terms here for the first 12 months. And the common difference is we're adding 6 every month, so positive 6. So the 12th month, 96. So it's n divided by 2, first term plus last term. So 30 plus the 96 times 6, as n is 12. And that gives us 756. Questions? All right, let's go through this one again to where everybody can see it. We know a rhombus has all congruent sides, right? We just don't know what they are. But they told us that the diagonal across from a 60-degree angle, so this diagonal, is 12. Well, we should also remember from a rhombus that the diagonals of a rhombus are perpendicular. Do you remember that? Or if we drew it in, can you see that? What it does is it takes this 60-degree angle up here and breaks it up into 2 30s. So now what I have is a 30, 60, 90 right triangle. If the whole thing is 12, what is this little half? 6. So if the short leg of a 30, 60, 90 is 12, what is the hypotenuse? Excuse me. If the short leg is 6, what is the hypotenuse? 12. So all sides are 12. And therefore the perimeter is 48. Okay? So that is one of our special right triangle problems with a twist. With a twist. Okay, let's take a look at your homework. See if you have any questions. Okay, did you label your axis and title your histogram?
Yeah.
Fabulous. Any questions about your histogram?
I've got a question.
Okay.
But not the histogram, but the classes.
Yes.
How do you know where to divide them up?
Okay. Were you okay getting the class width?
Yeah, I got that.
Okay. So your class width is 45. So what you do is you start with the lowest number, which is the 291.
Okay.
And that goes here, the 291. And then we add 45 to that to get the lower level of the next one. We add the 45 to that to get the low level of the next one. We add 45 to that to get the lower boundary of the next one. We add 45 to that to get the lower boundary of the next one. That's where these lower boundaries came from. And then the upper boundary is just one less than the lower boundary after it.
I was adding 45, and then I just...
You added 45 to this number to get that one?
I kept that.
Okay. We're going to add the 45 to the lower boundary to get the next lower boundary. So yours is probably just a tiny bit different, huh?
Yeah, it's a little different.
Does it make sense? Awesome. Okay. Today we're going to move into another measure of dispersion. What does dispersion mean?
Spreading out.
Spread. Good. Dispersion means spread. So we're going to look at another way to describe the spread of our data. We've already talked, well, you've already studied two different ways that somewhat discusses the spread of data. The first one you learned in elementary school. And it talked about how far apart your data was. What was that? Range. Okay. Then last year we studied a measure of dispersion. MAD, and that's what it made us, MAD. It was the mean absolute deviation. And that was another way to talk about the spread of the data. This year we're adding standard deviation, which is a widely accepted practice for discussing the spread of the data. We are going to do this today, and I'm going to teach you how to use my calculators. You can also use your graphing calculators, but the thing about the graphing calculators is you're not allowed to use those on the end of course test. So I would like to teach you how to use these so that you can manipulate the data on the end of course test a little more easily. So if everyone could go grab a calculator. Yes, those you can use on the end.
I should have got you guys, but I guess not.
Okay, and while you're up, you can put your responders back.
Jose, if you think for a second that I will trust you with my calculator. Okay, YouTube number 7, first of all, not cool.
I'll take
Oh shoot, I turned it on. I would barter a calculator.
What are you gonna barter it?
Why do you want to turn it off?
Takes a while.
They really will barter for number 7.
It turns me off. Camille, aren't you the leader? You the leader here right now? Still the lead, right?
It's not the lead, but it is a lead. It's the lead.
Okay, so now we all have our calculators. Let's go back and discuss some vocabulary here. We have two numerical values we're going to look at. Parameter is a numerical description of a population characteristic. So if we have the entire population versus a statistic is a numerical description of a sample characteristic. Now, a sample is what we usually deal with. If we had all the data for an entire population, we know what the data is. Unless we're predicting something that may happen in the future, we already know what everybody made. So when I look at your test scores, and I have every single test score, I'm good. I know what they are. But if I'm looking at a sample of test scores to try to predict what the entire population would be, that's where I'm looking at a statistic. Does that make sense? Okay. Now statistics are extremely valuable because a lot of times it's hard to get data on an entire population. The measure, some vocabulary in the measures of dispersion. Dispersion can be found for an entire population or just a sample, and we're going to talk about both of them, what we would do to find both. Range is the one we learned in elementary school. It's just the max minus the min. Variance. We're going to talk about variance, but you would use variance more if you took another statistics course, possibly in college, or if you plan on taking AP statistics here. When we look at the variance, it tells us what other types of tests we might want to use on our data. For us, we're going to calculate the variance, but we're not going to do a whole lot with the variance. But the variance is the sum of the squares of the means of the deviations. And variance is S squared for a sample and theta squared for a population. Now, standard deviation, this is our big one. It's just the square root of the variance. And we're going to use theta for the population and S for a sample. It's a measure of the typical amount that an entry deviates from the mean. How far away would a typical amount deviate from the mean? Now, we're going to slowly go through the steps. And I'll go ahead and tell you, most of you probably already know this, your calculator automatically spits out the answer for you. It's pretty cool. But I want you to understand the process. So on a couple, we are going to show every single step that the calculator has already done for us to spit out the answer. All right, so here are the steps. The first thing we're going to do is find the mean of the sample data. And mean is represented by the x bar. So to find the mean, we learned this long time ago. You add them all up and divide by how many pieces of data we have. Now, this symbol, this capital sigma here, Greek letter sigma, in mathematics stands for summation, which means to add up. So whenever you see a big capital sigma, this means add up all your x's. That's all it means. Now, the next thing is the deviation. Deviation is difference, right, from each entry. So what we do is we take each entry and subtract the mean from it. Deviate. How does it, what is the difference? Then we're going to square each of those deviations. So you take that difference and square it. Then we're going to add up all those squares. That's what this summation means. Add up all the squares of the differences. And then if we have a sample, we're going to divide by n minus 1. If we had the entire population, we would divide by n. So sample, n minus 1, the entire population you would divide by n. That's the difference there. That's all we got. Every other step's the same. And then the last step in finding the standard deviation is to take the square root of that. So this would be our variance here, and this is our standard deviation for a sample. Okay, let's take a look at the back of that page, and we're going to do one together. So, we've got these times. We've got 507, 389, 305, 291, 336, 310, 514, 442, 307, 337, 373, and 428. And what do these times represent? It represents the reaction time of a sample of 12 adult females to an auditory stimulus. So this is reaction time in milliseconds. I'd be closer to this 514. I'm slow. All right, so step 1 is to find the average. What is x bar? Well, how do we find average? Add them all up and divide by how many there are. But let's use our technology and make it do it for us. So what I'd like you to do is we're going to learn how to enter data onto these calculators, since these are the ones we're allowed to use. So what you do to enter data on these calculators is first you press the data button. That's where it goes. Okay, does everybody see L1, L2, L3? Okay, now some of you may have a lot of stuff in yours. So to get rid of the stuff, hit data again. You see you get a choice to clear. And if you go all the way down to choice 4, it says clear everything. Let's a good choice. Choice 4. Let's get rid of everything that's there. Okay, does everybody have
I
an
don't have
empty
choice.
data?
Choice 4.
Did you arrow down?
Yeah.
Okay, you hit data a second time. Okay, if you hit data once and arrow down to choice 4, it all goes away. Okay? All right, does everybody have an empty data table? All right, please go ahead and enter our data. 507. And when I enter data, I always arrow back up and double check my entry so that I make sure I haven't entered anything incorrectly. Oh, I'm good. Okay. Do we all have the data entered in L1? All right, so let's calculator find the average for us, X bar. So if you hit second and data, you see we can do one variable statistics. So let's arrow down to choice 2, which is one variable statistics. And we put our data in L1, so that's good. Hit enter. Frequency, we each piece of data to count once, so that's good. And hit calculate. And what is X bar?
378.
Yes, 378.25. Now, of course, we could have gotten that same thing, adding them up annually and dividing by 12.
That's exciting though.
Yeah, that is exciting. Okay, so now we know the mean is 378.25. Okay, now the second step in manually finding standard deviation is to find the difference between each piece of data and the mean. So let's make the calculator a little harder for us. If you'll go back to data, and if we arrow over into column 2, make sure everyone is in column 2 before you hit the next button, or it'll give you an error message. Okay, we're going to tell the calculator, take all that stuff in L1 and subtract this mean I just from it. And the way we're going to do that is if you hit data one more time, do you see you have a choice to enter a formula if you arrow over?
Yes.
We're going to enter a formula. And so arrow over and then hit enter for add formula. Well, what we want to do is take everything in L1 and subtract that 378.25 from it. Since we're in formula now, if we hit the data button one more time, do you see it gives us choices for L1, L2, L3? So select L1 and then do minus 378.25. And enter. And it does it for us. And we can copy it down.
I like this. And that's the deviation?
That is the deviation. So we're on our way. Okay. Now the next step in determining standard deviation is to square that. What do you think we're going to do?
L2 squared.
Okay, first we need to move over into what column?
3.
Move over into L3, and then enter a formula that makes it square L2. So hit Data, Formula, Add. And then hit Data again, and now choose 2 for L2, and then hit the square button, which is right beside the 7. And it has squared it for us. Did you get 16,577 as your first piece? Okay. Okay, now our next step is to find the sum of these squares. How would I add up all of these squares? What would I do? We can go to Second, Data for Stat, and do a one variable stat, but this time the data I'm looking at is in what column? L3, so arrow over to L3. Now, what represents a sum?
Oh, that thing you showed us.
Yeah, that thing I showed you. Does anybody remember the name of that?
Sigma.
The sigma.
Yeah.
Which one is sigma? When we
5.
choice 5. So the sigma is choice 5. It's the sum of all that data. Okay, we did a, right here we did one variable stat on L3. And you look at for sigma. Second, you have to do second data to get to one variable stat. And look at sigma, which is number 5. It's number 5. Oh, you just hit enter and you.
Let's go.
Get my agent. We're scheduling it out this weekend. Ryan's garage.
Okay. Now, to get the variance, because this is a sample, what do we take this 60,886.25 and divide by? N minus 1. So what is 12 minus 1? 11. So we're going to take that number, 67,886.25. We're going to divide by 11. And we get that the sample variance is approximately 6,171.48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48. 48 And then we take the square root of that. And we get that the standard deviation is approximately 78.559. Is that what y'all got? Or 56? Okay, so what we did was we showed every single step on what you do to find the standard deviation of a sample. First you find the mean, then you find the difference, then you square the difference, then you add them up, then you divide by n minus 1 because it's a sample, then you take the square root. Now, your calculator automatically did this on step 1. It automatically did every single one of these steps for us. Go back and do a one variable stat on L1 and see what the S was. The lowercase s for the sample standard deviation. Do a one variable stat on L1. Arrow down. Oh, you don't even have to, it's number 3. The sample standard deviation is number 3. Is it 78.559? Yes.
Oh my.
Okay, so the calculator does it for us automatically. But we need to understand the process, which is why I showed you how to manipulate the calculator to do it for you. So the process is, 1, find the mean, find the difference between the data and the mean, square that difference, find the sum of those squares, divide by n minus 1 for a sample, divide by n for a population, and then take the square root. Okay, there's another one beside this one on that page. This one, read to see if it's a sample or the entire population. The only thing that changes is either you divide by n or n minus 1. I'd like you to show all the steps on the one next to it. But when you get to the bookwork, you're allowed to use the shortcut of the calculator. Okay? So you don't have to show any work on the bookwork. You can just go straight to that cheating first step where you can see the standard deviation off the calculator. And you have the remainder of class to work.
And wait, how did you say we were going to